Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the 3D coordinates practice questions. If you need any extra help on 3D coordinates, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 86, is a dedicated video tutorial there on 3D coordinates. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at our first question. So we've got this cuboid, and it's a cuboid on a 3D grid. And remember, whenever we're dealing with 3D coordinates, they come in the form x, y, z. So we've got our x coordinate, our y coordinate, and our z coordinate. So we've been given two vertices. We've been given the coordinates of vertex C, which are 0, 0, 6. So 0 along the x-axis, 0 along the y-axis, and then 6 in the z-axis direction. So there. In terms of our coordinate E, we're told its coordinates are 20, 8, and 0. So that's 20 along the x-axis, 8 up in the y-axis direction, and 0 forward in the z-axis direction. So that's there. And then we've been asked to write down the coordinates of vertex A, so this point here. So to get to vertex A, we're going to be going 20 along in the x-axis direction because it's below E, so we know we're going to be going 20 along in the x-axis direction. We're not going to be going up in the y-axis direction or out in the z-axis direction, so our coordinates for point A will be 20, 0, 0. So that's the coordinates of point A. So point A is 20, 0, 0. Okay, part B. Part B says write down the coordinates of vertex B. So let's look at our vertex B, so this point here. So this point here, B, we're going to be going 20 along in the x-axis direction. We're not going to be going up in the y-axis direction because, as you can see here, it's on the base of the cuboid. So we're going to be going 20 in the x-axis direction. Then our y-coordinate will be 0. And then in terms of our z-coordinate, well, let's have a look at C. It's in line with C, and C is 6 along in the z-axis direction, so it will be 6. So the coordinates of point B will be 20, 0, 6. So let's write that down, 20, 0, 6. Okay, part C. So part C says write down the coordinates of vertex F. So vertex F is this point here. So to get to vertex F, we'll be going 20 along in the x-axis direction, 8 up in the y-axis direction, and 6 out in the z-axis direction. So it's going to be 20, and then we'd have 8, and then we'd have 6, because it's going 20 in the x-axis direction, 8 in the y-axis direction, and then 6 forward in the z-axis direction. So that's it, 20, 8, 6. So 20, 8, and 6. Okay, let's have a look at our next question, question number 2. So question number 2 says, below is a cube on a 3D grid. So we've got this cube on a 3D grid, so this is a cube. And we're told the coordinates of vertex B, so vertex B, the coordinates of this point are 8, 0, 8. So the coordinates of this point, remember the coordinates in the form x, y, and z. So the coordinates of this point here, B, will be 8, 0, and 8. And what that means is to get to this point, we'll start off with the origin. We'll be going 8 along in the x-axis direction, 0 up in the y-axis direction, and then 8 forward in the z-axis direction. So 8, 0, 8. And then part A says write down the coordinates of vertex F, so this point here. Well, we'll be going 8 in the x-axis direction, 8 in the y-axis direction, and then 8 forward in the z-axis direction. So it's going to be 8, 8, 8. That's the coordinates of the point F. So let's write that down. 8, 8, 8. Okay, part B. Part B says write down the coordinates of vertex G. So vertex G is this one here. So to get to this point, well, we're not going to be going across in the x-axis direction. We're going to be going up 8 in the y-axis direction and then 8 forward in the z-axis direction. So that'll be 0, 8, 8. So the coordinates of this point G will be 0, 8, 8. 0 in the x-axis direction, 8 in the y-axis direction, and 8 forward in the z-axis direction. So 0, 8, 8. And that's it. Okay, our next question. So question number 3. Question number 3, we've got this cuboid, and we've been told the diagram shows a cuboid drawn on a 3D grid. So it's a cuboid on a 3D grid. And we're told the coordinates of point C, so this point here, are 5, 2, 3. And remember, they come in the form x, y, and z. So we've got our x coordinate, our y coordinate, and our z coordinate. So at this point here, we'll be going 5 in the x-axis direction, 2 up in the y-axis direction, and then 3 forward in the z-axis direction, and that's the coordinates of the point C. Okay, so part A says write down the coordinates of point A, so that's this point here. So we wouldn't be moving across in the x-axis direction. We're going to be moving up 2 in the y-axis direction because it's in line with C and B, so that is 2 up in the y-axis direction. And it's not going to be moving forward in the z-axis direction, so it'll be 0, 2, 0. That's the coordinates of that point, 0, 2, 0. So 0, 2, 0. And then in terms of part B says write down the coordinates of point F. So point F is here below C, so this point here. So the coordinates of this point will be 5 in the x-axis direction, so 5. And then we're not going to be moving up in the y-axis direction because it's on the base of the cuboid, so it's going to be then a 0. And then we're going to be moving 3 forward in the z-axis direction, so it's going to be 5, 0, 3. So 5, 0, 3. Okay, and then we're told that H is the midpoint of FG. Write down the coordinates of point H. So let's go up FG. So F and G. So here's F and here's G. So the coordinates of F are 5, 0, 3. The coordinates of point G are, well, we're going 0 across in the x-axis direction. We're going 0 up in the y-axis direction, so 0, 0. And then we're going to be coming 3 forward in the z-axis direction, so 3. So that's 0, 0, 3. So we've got the coordinates of F and G, and H is the midpoint of that line. So that's going to be the point H. So if we want to find the coordinates of the point H, one approach would be to consider, well, how do we get here? Well, instead of going 5 across in the x-axis direction, we're going to be going halfway across. So it's going to be 2.5 across. And then we're going to be going 0 up in the y-axis direction. So then that'll be 0. And then we're going to be moving 3 forward in the z-axis direction. So the coordinates of this point H will be 2.5, 0, and 3, because we're going halfway along to E, so halfway, so that'll be there, 2.5. We're going to be moving 0 up and then 3 forward, and that brings us to the midpoint of G and F. Another way is to just add the two coordinates together and half them. So let's write the two coordinates down here. So we had 0, 0, 3, and we've got 5, 0, 3, and we want to find the midpoint of the line passing through those 2 points. So in terms of finding the midpoint, we could add them together and half it. So 0 plus 5 is equal to 5, and then half that will be 2.5. 0 plus 0 is equal to 0, and half that is 0. And 3 plus 3 is 6, and half that is 3. So we could just add them together and half it, and that's a way you can find the midpoint of two coordinates. And in terms of it, this approach is the same approach as dealing with 2D coordinates, apart from we've just got that extra z coordinate. Or another way is you can learn the formula. So the formula for it would be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, comma, z1 plus z2 divided by 2, close brackets. And that's just the same as just saying add together the x coordinates and divide by 2. So that's what we've done to get our 2.5. Add together the y coordinates and divide by 2. And add together the z coordinates and divide by 2. And that's what we've done. And that's it. Okay, let's have a look at the next question. So question number 4, we've got this cuboid on a 3D grid, and we've been asked to write down the coordinates of the point A, so this point A. So to get to A, we'll be going 12 along in the x-axis direction, so 12. We'll be then going up 8 in the y-axis direction, so 8. And then we're going to be coming forward 6 in the z-axis direction, so 6. So the coordinates of this point A will be 12, 8, 6. And remember, it's in the form x, y, and z. Okay, part B. Part B says write down the coordinates of the point B. So we want the coordinates of this point here, point B. So to get the coordinates of this point here, we'll be going 12 across in the x-axis direction. We're not going to be going up in the y-axis direction, so that'll be a 0. And then we're going to be moving 6 forward in the z-axis direction, so 6. So that'll be 12, 0, 6. 12 across, 0 up, and 6 forward. And that's it, so 12, 0, 6. And then we're told the point C is the midpoint of AB. Write down the coordinates of point C. So C is the midpoint of AB. So we've got AB here, and C is the midpoint, so C is in the middle there. We want to find the coordinates of this point here. So we've got the coordinates of point A are 12, 8, 6. We've got the coordinates of point B are 12, 0, 6. And then if we want to find the coordinates of the midpoint, we can add them together and half it. So let's write down the coordinates of point C. So they would be, adding them together, 12 plus 12 is 24, and half of that would be 12. 8 plus 0 is equal to 8, and divide by 2 would be 4. And then finally, 6 plus 6 is equal to 12, and half that would be 6. So the coordinates of this point C would be 12, 4, 6. So let's write that down, 12, 4, 6, 12, 4, 6. And that's it. Okay, let's have a look at our next question, question number 5. So question number 5 says, here's a cuboid drawn on a 3D grid. So we've got this cuboid on a 3D grid. And part A says write down the coordinates of point C. So we want to write down the coordinates of this point here. So to get to this point here, well, remember the coordinates are in the form x, y, and z. So if we have a look at the point B, it's 12 across and then 4 up. So it's going to be 12 across and 4 up to get to here. So 12 across and 4 up. And then we're going to be moving forward. If we have a look at G, it's been moved forward 3. So we're then going to move forward 3. So it's going to be 12, 4, 3. 12 across, 4 up, and 3 forward. And that's how you get to this point here. Okay, part B. Part B says write down the coordinates of point F. So the coordinates of point F, that's this point here. Well, again, you're going to be moving 12 across to get to E. We're not going to be moving anything up, so it's going to be 12 and then 0, because that would bring us to here. And then we do want to move 3 forward to get to F, so it's then going to be 3. So it's going to be 12 across, 0 up, and 3 forward. So that's the coordinates of the point F, 12, 0, 3. Okay, and our next part, part C, says write down the midpoint of the line segment BG. So let's connect up B and G, so that's going to be there, that's the line BG. I want to find the coordinates of the midpoint, so that's the coordinates of the midpoint there. So we've got the coordinates for G and the coordinates for B. If I want to find the coordinates of the midpoint, I'm just going to add them together and half it. So 12 plus 0 is equal to 12, divided by 2 would be 6. Then 0 plus 4 is equal to 4, divided by 2 would be 2. And then 3 plus 0 is 3, divided by 2 would be 1.5. So the coordinates of this point, the midpoint of BG, would be 6, 2, 1.5. Okay, let's have a look at our next question, question number 6. So question number 6, we've been given a square-based pyramid drawn on a 3D grid. So we've got this square-based pyramid, and we've got the coordinates of the point D, so the vertex D are 4, 9, and 4. So the coordinates of point D are 4, 9, 4. And remember, they're in the form x, y, and z. And then we're told M is the center of the base, O, A, B, C. So M is the center of the square, and D is directly above M. So D is directly above M. So let's find out the coordinates of the point M, the coordinates of the center of the base. So in terms of D, it's 4 along in the x-axis direction, it's 9 up in the y-axis direction, and it's 4 forward in the z-axis direction. Well, in terms of M, well, it's going to be 4 across in the x-axis direction, so 4. And now we're not going to be going up because it's on the base M, so it's the center of the base, so it's then going to be 0. We're not going up in the y-axis direction, but we would still be coming forward 4 because it's directly below D. So if we have a look at it, we've got the coordinates of point M are 4, 0, 4, and that's just 9 directly below the point D because it's just 9 squares directly below it. Okay, and then the question says, find the coordinates of the point B, so the coordinates of this point B. Well, let's think about it. To get from O to M, we'll be going 4 across, 0 up, and 4 forward. So to get to point B, we'll be going, instead of going 4 across to the midpoint, we're going to go 8 across, 0 up, and then 8 forward. So it's going to be 8, 0, 8. And that's it. So the coordinates of the point B will be 8, 0, 8. So what I've done there was I just considered how to get it from 0 to M, 4 across, 0 up, 4 forward. And to get to M, which is the whole way across the square, you'd go 8 across, 0 up, and 8 forward. Or another way you could have considered this question is to think, well, if M's the midpoint and it's 4 across, the length of the base here will be 8, so that would be 8, and then that would be 8, and that would be 8. So to get from O to M, you'll be going 8 across, 0 up, and 8 forward. And that's it, so 8, 0, 8. Okay, let's have a look at our next question, question number 7. So we've got this cube on a 3D grid, and we've got the cube A, B, C, D, E, F, G, H. So that's the cube. And we're told, so the coordinates of the vertex A are 7, 0, 0, and the coordinates of vertex B are 12, 0, 0. And we've been asked to write down the coordinates of vertex G, this point here. Okay, so we want to find the coordinates of this point. Now the first thing I've noticed is that O, A, and B are all on a straight line. They're all on the x-axis. And to get from A to B, we're going to be going another 5 across. So that means to get from A to B, we're going to be going 5 across. That means the length of the base of this cube is 5. And because it's a cube, that means that this would be 5 and this would be 5 and so on. So if we wanted to get the coordinates of vertex G, this point here, we would be going from O to B, so it's going to be 12 across because we're going 12 across in the x-axis direction. We're then going to be going up 5 to get to F, so then going up 5 in the y-axis direction. And then we're going to be coming forward 5, so because obviously all the lengths of this cube are 5, so that'd be 5. And that's it. So the coordinates of this point G would be 12, 5, 5. 12 across in the x-axis direction, 5 up in the y-axis direction, and 5 forward in the z-axis direction. So that's 12, 5, 5, and that's it. Okay, let's have a look at our next question, question number 8. So we've got this cuboid, and we're told the coordinates of vertex E, this point here, are 0, 18, 0. So that's the coordinates of this point E. And the coordinates of point D, this point here, are 0, 0, 10. So we've got the coordinates of E and the coordinates of D. So if we have a look at this, this is a cuboid. So we know to get from O to E, we're going 0 across in the x-axis direction. We're going 18 up in the y-axis direction. That means the height of this cuboid is 18. So I'm just going to put an 18 there for the height of the cuboid. To get from O to D, well, we're going 0 across in the x-axis direction, 0 up in the y-axis direction, and then 10 forward in the z-axis direction. So it means that this length here on this cuboid is 10. And we are then told that the point P lies on EF such that EP to PF is 2 to 3. So the ratio of this length to this length is 2 to 3. And then we're told that Q, the point Q, lies on DC such that DQ to DC is equal to 4 to 5. So in other words, if that's parts 4, the whole part's 5 because from DQ to DC. So if this is 4, this is 5 the whole way across. And then we're told, if we have a look at the question, we're then told that the coordinates of point P, so point P, this point here, are 12, 18, 0. And the question asks us to find the coordinates of the midpoint of PQ. So you want to find the coordinates of the midpoint of PQ. So what I'm going to do is I want to first of all find the coordinates of the point Q. So if we can find the coordinates of this point Q, we can then find the midpoint of PQ. So let's focus on finding the coordinates of the point Q. Now in terms of finding the coordinates of the point Q, it'd be fantastic if we knew what the length of this cuboid was, so the distance from O to B or from E to F. And actually we can use the information we're told in the question to work that out. Because in terms of the point P, we know it's 12 across, 18 up and 0 forward. Now we know it's 18 up because it's in line with E, and we know it's 0 forward because again it's in line with E and F, but also we know that it's 12 across. So that means the length of this part of the line is 12. So it would be fantastic if we could work out the length of this part of the line. And we're told that the ratio of EP to PF is 2 to 3. So if we take the 12 and we divide it by its number in the ratio, which is 2, we get that's equal to 6. And then if we take the 6 and multiply by the other number in the ratio of 3, that's equal to 18. So that means that if the length of this part is 12, the length of this part is 18. So that means the whole way across from E to F would be 30, because 12 plus 18 is 30. So the length of the cuboid is 30. And that's fantastic, because that's going to help us find the coordinates of the point Q. Okay, so let's find the coordinates of the point Q. So in terms of the point Q, well, we know we're going to be going a certain number along in the x-axis direction. We don't know that yet. We're not going to be moving anything up in the y-axis direction, so it's going to be something, and then 0. And then in terms of how much forward it's going, because we know it's obviously, if we move, it's in line with D and C, so it's moving 10 forward. Okay, so in terms of the point Q, it's so many along in the x-axis direction, we don't know that yet. It's 0 up in the y-axis direction, and it's 10 forward in the z-axis direction. Now what we do need to find is this x-coordinate for Q. Now in terms of that, we know the ratio of dq to dc, because this is 4 to 5. Now if this is 4 and the whole thing is 5, that means that this would be 4 and that would be 1 in terms of the ratio. 4 parts to 1 part, because that would be 4 to 5 altogether. So if we divide 30 in the ratio 4 to 1, we can then find the length of dq. So let's do that. So let's do 4 plus 1. 4 plus 1 is equal to 5. 30 divided by 5 is equal to 6. And then if we take our 6 and multiply by 4, that's equal to 24. So that means that this length from D to Q would be 24, and the length from Q to C would be 6. Because 24 to 6, that adds together to be 30, the whole way across the cuboid. And if we just check the ratio, dq to dc, that's 24 to 30, and if you cancel that down, that's 4 to 5. So that means dq is 24. So in terms of finding the coordinates of the point Q, it's going to be 24 across, because that would bring us to here. It's then going to be 0 up, and then it's going to be 10 forward. So the x-coordinate is 24. Okay, this is fantastic. We now know the coordinates of the point P and the point Q. Let's join them up. And we've been asked to find the coordinates of the midpoint of that line, so the coordinates of the midpoint of that line. So if we want to find the coordinates of the midpoint of this line, we're going to add together the coordinates and half it. So let's do that. So let's actually write down the coordinates. P is 12, 18, and 0, and Q is 24, 0, and 10. And let's add them together and half it to find the coordinates of the midpoint. So that's going to be, in terms of the coordinates of the midpoint, it's going to be 12 plus 24 divided by 2, because we're adding together the x coordinates and then dividing by 2. Now let's add together the y coordinates and divide by 2, so 18 plus 0 divided by 2, and then we've got 0 plus 10 divided by 2. So adding together the x coordinates would be 36, divided by 2 would be 18. Adding together the y coordinates, 18 plus 0 is 18, divided by 2 would be 9. And adding together the z coordinates, 0 plus 10 is 10, divided by 2 would be 5. So that means the coordinates to the midpoint of PQ would be 18, 9, 5. And if you got that, well done. Okay, let's have a look at question number 9. So question number 9, we're told that 0, 0, 0, 6, 0, 0, 0, 20, 0, and 0, 0, 8 are vertices of a cuboid. And we're told that C and D are also vertices of the cuboid. So we've got this cuboid, and we've got 0, 0, 0, 6, 0, 0, 0, 20, 0, and 0, 0, 8. They're the coordinates of those corners. And then we've got the point C and the point D. And then part A says, work out the distance between O and C. So we want to find the distance between O and C. So let's join them up. So we want to find the length of that line. So if we have a look at the base is a rectangle. So that means that's a right angle there. And it means we're going to be using Pythagoras' theorem. Because we know to get from O to this point here, we're going to be going 6 across. And to get from O to this point here, we're going to 8 across. That means that from here to here is also 8. So it's a right angle triangle where you've got this is 6 and this is 8. And we can use Pythagoras' theorem to find the length of the hypotenuse. So let's just call that h for the minute. So in terms of Pythagoras' theorem is a squared plus b squared equals c squared. So the two shorter sides of this right angle triangle of the base will be 6 and 8. So it's going to be 6 squared plus 8 squared equals c squared. That's the hypotenuse. That's going to be h squared. 6 squared is 36, 8 squared is 64, that equals h squared. Adding those together will be 100 equals h squared, and then we just square root. So if we do the square root of 100, that's equal to 10. So that means the h is equal to 10. So that means the distance from O to C is equal to 10. So let's write that down, 10. Okay, and then part B. Part B says work out the distance from O to D. So we want to get from O to D. And actually, if we have a look at it, we've got another right angle triangle. We've got this length here. We know this, instead of being h, is now 10. Now I'm just going to replace that h with 10 because we've worked that out to be 10, and we're going to use it for our next question. We've got OC is 10. We've got this vertical line going up from C to D, so that's a right angle triangle there. And then we've got this longer side, this hypotenuse OD. And in terms of the length from C to D, well, that's the height of the cuboid, which is 20, so that's going to be 20. So we've got a right angle triangle there. Let's sketch that, actually. Let's sketch it up here. So we've got O, C, and D, and there's our right angle, OCD, and that's a right angle there. To get from O to C, that's 10 across. To get from C to D, that's 20 up, and we're trying to find this hypotenuse here. So let's call that H. We want to find that hypotenuse there. Okay, so we want to find the length from O to D. So let's use Pythagoras' theorem again. That's going to be a squared plus b squared equals c squared. So that's a squared plus b squared equals c squared. A squared, well, that's going to be 10 squared plus b squared, that's going to be 20 squared, equals c squared, that's going to be h squared. 10 squared, 10 times 10 is 100, plus 20 squared, 20 plus 20 is equal to 400, is equal to h squared. H squared that means is equal to 500, and then if we square root that, the square root of 500, that's going to be the length of OD. So let's work that out. So the square root of 500 is 10 root 5, or 22.36067977, or to two decimal places, 22.36. And that's it. So the length of OD is 22.36. And that's it. Okay, let's have a look at our next question. So here's question number 10. So we've got this cuboid, and we're told that vertex G, this vertex here, has got coordinates 9, 6, 4. That's the coordinates of that point G there. And part A says work out the length of OC. So we want to find the length of OC. So let's draw that line on our diagram from O to C. And we're going to be using Pythagoras' theorem again here, because as you can see, we've got this right angle triangle. There's a right angle triangle. And because we know the coordinates of the point G, remember, they're in the form x, y, and z. So we've got our x coordinate is 9, so that's 9 across here. So that means the length of that side of the triangle is 9. And then we want to find this length here. Now, in terms of that direction, that's the z-axis direction, so it's going to be our 4. So it's going to be 4 forward, that way. The 6 here would be actually the height of the cuboid. So we've got, in terms of this triangle, we've got the two shorter sides, and we want to work out the length of the hypotenuse. So in terms of finding the length of this hypotenuse, OC, we're going to be doing a squared plus b squared equals c squared. A squared, that's going to be 4 squared, plus b squared is 9 squared, equals the longest side squared, which would be h squared. 4 squared is 16, plus 9 squared is 81, and that's equal to h squared. And then if we add those together, we get that's 97 is equal to h squared. So h is equal to the square root of 97. So the length of OC is equal to root 97. So that's equal to the square root of 97, or if you give it as a decimal number, 9.849 to 3 decimal places. That's the length of OC to 3 decimal places. Okay, then part B. Part B says calculate the size of angle COG. So that's angle COG. I'm actually just going to draw another line on our diagram, so the line from O to G. And we've been asked to find the size of this angle here, the size of this angle in here, angle COG. So we want to find the size of that angle. I'm going to call it beta. We want to find the size of that angle. I'm actually just going to move that 9 to here, just so we know that it's the distance across there. And in terms of this triangle, at the minute, we know one of the lengths. We've just worked out OC, that's equal to, and I'm going to leave it as a third, root 97. I'm doing that so that I don't have to type in the whole decimal number in my calculator display. So from O to C is root 97. And then in terms of, we've got the height of the triangle, because the height of the triangle is going to be the height of the cuboid, which is 6. So it was 6 up. So we've got a triangle there, we've got the lengths of 2 of the sides, and it's a right angle triangle as well, so we can use trigonometry. So let's sketch this triangle. Okay, so we've sketched a triangle where we've got our root 97 being the distance from O to C. Actually, just check if we label that right. OC and then G at the top. So we've got OC is equal to root 97. CG is equal to 6, the height of the triangle. And we want to find the size of the angle. So let's label our sides. We've got the opposite, we've got the adjacent, and we've got the hypotenuse. Now this question we've not been given and we're not trying to find the hypotenuse, so we can cross that out. And that means in this question we're going to be using tan. The tan of the angle, tan vita, will be equal to the opposite divided by the adjacent. So the tan of this angle is equal to the opposite, which is 6, divided by the adjacent, which is root 97. So that means that if we do 6 divided by the square root of 97, that would give us the tan of the angle. But we want to find the angle, so we're going to do the inverse tan. So vita is equal to the inverse tan of 6 over the square root of 97. And let's just type that into our calculator. And that, whenever you press equals, it will give you an answer of 31.35 degrees. And that's it. We've found the size of angle COG. And that's it. So in this video, we've gone through the video solutions to the 3D coordinates practice questions. I really hope you found it useful. If you need any extra help on 3D coordinates, if you go to the videos and worksheets section on the website, video number 86 is a useful one for you. Alternatively, you can scan this QR code. But in this video, we focused on the video solutions to the practice questions. I really hope you found it useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.